Let us look at question number 41 now, students. The correct relative rate of alkaline hydrolysis is. So we've been given 4 different compounds A, B, C and D, and the examiner seems to be interested in comparing the rate of alkaline hydrolysis for A, B separately and C and D separately. Okay. So if you talk about compounds A and B, students, we know that in compound B, the plus M is effective. So if we talk about A and B, students, in the compound B, the plus M is more effective. This lone pairs over nitrogen can be delocalized or can be in conjugation with the carbonyl group. Whereas if we talk about the first compound now, in the first compound there is a cyclic amide, and due to this strain, this resonance will not be very much effective. Okay. So due to this resonance happening, students, the electrophilicity of this carbonyl carbon will decrease. So if we talk about the magnitude of charge, if we call it delta positive, so this delta positive will decrease over this carbon. And so if we talk about the relative rate of hydrolysis in the alkaline medium, the OH minus will prefer to attack this carbon as there is no resonance with the lone pair of nitrogen happening in this case. So if we talk about A and B, students, we can see that A is more reactive than B. And if we talk about the compound C and D now, similarly, all that is left is to compare the plus M. So in the compound D, the lone pairs of nitrogen can be delocalized with the carbonyl group. Okay. And if we talk about the compound C now, in the compound C there is a bridgehead nitrogen. So the bridgehead nitrogen will not be able to delocalize its lone pairs with the carbonyl group. So students, again, due to this resonance happening, the delta positive on the carbonyl center, it decreases, and given the option, the OH minus would like to attack over here as the electrophilicity is greater for this carbonyl carbon. Okay. So if we talk about the reactivity of C and D, students, we can clearly see that C is more reactive than D. If you look at the options which are given to us, students, we can clearly see that we have to mark the correct answer to this question as option 4. Okay. So A is more than B and C is more than D. Okay. Question number 42. Which one of the following compound react with nitrous acid to give the product B? Okay. So if we start with the first option, students, we have been given the structure. Okay. So when this is allowed to react with HNO2, students, the HNO2 will convert this NH2 into N2 plus and it will make it leave. So it is a good leaving group, students, and this will be leaving from here, and the lone pairs over oxygen which are anti to the leaving group, they will attack intramolecularly on this carbon, so leading to the formation of an epoxide ring. As shown to us in the compound P. Okay. So students, we can clearly see that this has to be marked as the answer to this question. The first option is the only option in which the OH and the NH2 are both at the axial positions and the NH2 is leaving in the form of N2 on reaction with nitrous acid. Okay. So students, the correct answer for question number 42 is option 1. Question number 43. Consider the following statement. So S1, it says sucrose is a non-reducing sugar. This is a correct statement, students. Sucrose is non-reducing. If you talk about statement 2 now, students, glucose on oxidation with nitric acid forms gluconic acid. This is not correct, students. Glucose on oxidation with nitric acid, it forms glucaric acid or saccharic acid. So HNO3 forms aldaric acid. Okay. Whereas mild oxidizing agents such as bromine water, they form aldonic acid. So this is glucaric acid and not gluconic acid as mentioned in the option. So S2 is incorrect. If you talk about statement 3 now, valine, leucine and arginine are essential amino acids. This is a correct statement, students. If If we talk about the fourth option now, aspartic acid is an acidic alpha amino acid. So this is also correct, students. So the examiner seems to be interested in the incorrect statement, students, and we can clearly see that S2 is incorrect and we have to mark the correct answer to this question as option 2. Okay. Question number 44. Consider the following polymer. If we look at the compound given to us, students, we can clearly see that this polymer consists of melamine, and then there is a CH2 group which must have come from the formaldehyde. Students, this is a melamine formaldehyde resin or melamyl formaldehyde polymer, and if we look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option 2. Question number 45. Select the homopolymer that is formed by the addition polymerization. So there are two conditions asked by the examiner in this question, students. It has to be a homopolymer and then it also has to be formed by the addition polymerization. Okay. So if we talk about Teflon, students, Teflon is polytetrafluoroethene C2F2, which can be represented as this. So this undergoes polymerization to give us Teflon. So this is a homopolymer and it is also formed by the addition polymerization or the free radical polymerization, students. So this has to be the answer. If we talk about Buna N is not a homopolymer. It consists of butadiene and acrylonitrile. If we talk about Buna S, this is also not a homopolymer. It consists of butadiene and styrene. Okay, and if we talk about bakelite is formed by the condensation of phenol and formaldehyde. Okay, so bakelite is also not a homopolymer. It consists of two different monomers. So this bakelite is also a copolymer. Okay, so for question number 45, students, we can clearly see that the only polymer which satisfies both these conditions is Teflon. Okay, so for question number 45, we have to mark the correct answer as option 1.